Welcome to the Fundora. Today, we're getting into something really fundamental, this idea of a new industrial revolution.
Right.
But it's not about factories making, physical stuff. It's about making intelligence.
Yeah, exactly. We're talking about Jensen Huang's vision for Nvidia, this Huang doctrine.
We're going to unpack that today. It's this big plan to really reshape computing and honestly, maybe the whole global economy.
That's the goal. And we'll look at Nvidia's strategy, these three main pillars they have, the hardware, the software, and how it connects to the physical world.
And the challenges too, right? Because it's not all smooth sailing.
Definitely not. It's about understanding this core shift.
Yeah.
Computing isn't just using intelligence anymore. The idea is it's starting to manufacture it. That could change everything digitally.
Okay, so let's start there. This shift. How does Huang see computing changing from what we're used to?
Well, the big idea is moving past just like looking up information or processing data.
Retrieval. Yeah.
Right. To becoming generative.
Yeah.
To actually creating intelligence. It's a massive redefinition of what computers are even for.
And he calls the place where this happens an AI factory, not a data center.
Exactly. And that term is deliberate. Not just an IT cost center anymore. It's a production facility.
Producing what exactly?
Intelligence measured in tokens.
And
he's got this economic line, the more you buy, the more revenue you get, which sort of forces businesses to ask, how much intelligence do we need to make?
That's a huge strategic question. And this AI itself, Huang sees it evolving in stages.
Yeah, 4 stages he lays out. We had perception AI for about the last decade.
Like image recognition, that kind of thing?
Exactly. Then generative AI hit big in the last 5 years or so. Now, he says we're entering the agentic AI phase.
Agentic, meaning like digital agents?
Kind of like digital workers or digital employees. AI that doesn't just generate text or images, but performs tasks, augments human workflows. They're even using them inside Nvidia now.
Wow. And the final stage?
That's physical AI, robots basically, powering the next wave of automation.
And I assume each stage needs more grunt, more power.
Oh, exponentially more. Agentic AI alone needs way, way more compute than we first thought. And that, of course, drives huge demand for NVIDIA's next-gen stuff.
So let's talk about that stuff. The first pillar is the hardware, right? They seem to be on this crazy fast release cycle. Blackwell, Rubin, Feynman. It's relentless.
It is an annual cadence. But the really key shift isn't just faster individual chips.
What is it then?
It's selling these complete data center scale systems. Think the GB200 NVL72. It's not just a GPU. It's a whole liquid-cooled rack.
72 GPUs, 36 CPUs, all in one box?
Yeah, capable of an exaflop. Just insane power. And you need advanced networking, like their Spectrum X, just to connect it all and make it work efficiently.
Okay, so massive integrated hardware. What's the second pillar? Software. CODA comes to mind.
CODA is absolutely a foundation. It's deeply embedded everywhere. But they're pushing hard now into AI inference. That's the running of trained models, which is a potentially bigger market than training.
Okay, but what do they do in that?
Well, things like NVIDIA Dynamo. It's sort of an open-source AI operating system for inference and NIMs.
NIMs.
NVIDIA Inference Microservices, basically pre-packaged, optimized AI models ready to deploy. They call it a disintegrated for integration model. You can buy the pieces.
But it works best if you buy the whole NVIDIA stack.
That's the incentive, yeah. It offers flexibility, but strongly nudges you towards their full optimized solution. Pretty smart.
Okay, hardware, software, what's the third pillar? You mentioned connecting to the physical world.
That's NVIDIA Omniverse. They position it as the operating system for physical AI. Think industrial digital twins.
So, like simulating factories or robots.
Exactly. And crucially, generating synthetic data. You need vast amounts of data, often data that's hard or dangerous to get in the real world, to train autonomous systems, especially humanoid robots.
Like their Project GR00T initiative?
Precisely. Omniverse is meant to be the simulation engine, the training ground for that next wave of physical AI.
It all sounds incredibly ambitious, almost sci-fi. But you mentioned headwinds, challenges. What are the big ones?
Well, competition's definitely ramping up. AMD is pushing hard on price performance plus their open-source ROCm software alternative. Intel's in the game too.
And Nvidia's own customers are building chips now, aren't they?
That's a huge factor. Google with TPUs, Amazon with Trainium and Inferentia. The hyperscalers want to control their own destiny, reduce dependency.
Okay, competition. What else?
Geopolitics is massive. The US-China export controls have cost Nvidia, Jensen Huang said, multiple billions of dollars in potential revenue. And it's pushed China to accelerate its own AI hardware, boosting competitors like Huawei significantly there.
That's a big risk. Any internal issues? Execution?
There are some. Omniverse, for instance, despite the vision, has faced criticism about its usability. Some developers have apparently called it a very difficult to use, maybe more marketing tool than mature product right now. So adoption and execution remain hurdles.
So summing up, Jensen Huang's vision is just immense, architecting the whole computational base for a new era.
It really is. The key thing is balancing their incredible strengths, their lead in tech, that massive ecosystem, against these really serious challenges, competition, geopolitics, making sure these ambitious platforms actually deliver smoothly.
And for you listening, it really brings home that quote from Huang. The threat isn't AI taking your job, it's you're going to lose your job to someone who uses AI. How do you adapt your skills for that world? Something to think